Welcome back to Learning with me, Ms. Killen here at MPB. We're on our last lesson of Unit 3, Inequalities. So for our last lesson, we're going to work and solve these inequalities. So let's look and see what we've got. We're looking at Lesson 5. We are working and solving simple and compound inequalities. We're looking at standards REI.3 and CED1. We can say that we can solve inequalities for possible solutions, and this whole unit is going to be a time for us to master. So what we're going to do in this unit is I'm going to read our problems, and then I'm going to give you time for you and or your table partner to work these problems, and then we're going to come back and then we're going to compare and maybe have a little discussion on this. So let's go ahead and see what we've got. Okay, the first thing it tells us to do is be on the lookout for negative coefficients. When solving inequalities, you will need to reverse the inequality symbol when we what? Multiply or we divide by a negative. So that's one thing that we've got to make sure that we are looking for, those negative coefficients when we're getting those variables by itself. So here we go. Amir wants a new electric bicycle. Amir is saving money to buy the bicycle that costs $180. She already has $45 and she will save $15 per week from her paycheck at the gas and go. Write and solve an inequality to find the minimum number of weeks she must save to afford the bicycle. So go ahead and pause the video, and then once you or you and your table partner get your answers and get your work, come back to me and let's see what we got. Are y'all ready to work on this bicycle? So let's see what we got. I'm going to annotate my passage. You look at my annotations and see if it looks anything like your annotation. So here we go. It says that she's saving money for her bicycle that cost $180. She already has $45, and she's going to save $15 per week. All right, so we're going to solve and we're going to write our inequalities, and we're looking for the minimum number of weeks it's going to take. Now, this bicycle costs $180. Now, what she has to save has to be either equal to or greater than that $180. Well, you're probably sitting there going, why greater? Well, if she has less than $180, she's not going to walk out the store with the bicycle. So she's got to have either the $180 or more. So let's look and see what we got. So it's got to equal or it's got to be bigger how much we save. Now, I already know that we have $45. It says that she has $45, and she's going to save $15 each week. So if I put those together, I should be able to find out how many weeks. So let's go ahead and look at the math. Here we go. So the first thing I'm going to do is subtract my 45 on both sides. And I have my 15W is greater than or equal to 135. I'm dividing by that 15. So my W has to be greater than or equal to 9. So now that we have solved, what does that answer mean? This is when we're going to write a statement saying this is what W is greater than or equal to 9. So look at my statement. So my statement's going to say she must save for at least, meaning more, she could do more, but at least 9 weeks. So that means after 9 weeks, she should have enough money. If she saves more, obviously she'll be able to buy it, but she's got to save at least that whole 9 weeks of her paycheck. Good job. So let's look at the next one. All right. So the next one says, it's soccer season. A school's soccer team accepts between 13 and 17-year-old, inclusive of 13, but not 17. Write and solve an inequality that shows the acceptable ages to join the team. Write and solve the inequality. So go ahead and you and your table partner pause the video, work your problem, annotate your passage, see what you get, and then come back to me. Okay, soccer season. My house is a really, really big soccer house, so we always watch the soccer games. So let's see what this school's got. Now, it says it accepts between 13 and 17-year-olds inclusively of 13. They must be 13. But they don't necessarily have to be 17. But they have to 100% be 13 years old, no matter what. So then it says, write and solve an inequality that shows the acceptable age to join the team. So I know that at 13, I have to equal or be greater. And then I have my age. And that age has to be less or equal to 17. All right, so I already have what my inequality could be. So let's take it one step further and let's graph it. All right, so here we go. Let's graph it. You ready?
You said you can just start from there when you're ready.
All right, so let's go ahead and graph this. So I'm going to draw my number line with 0, 13, 17. Now, before I graph, I always want to go back and make sure that my inequality says exactly what my problem says. Now, inclusive of 13, it has to equal, but not 17. So my inequality here just has to be the less than symbol. All right? So it's a good thing that we always go back and look at that inequality, because sometimes you're reading so fast and you're wanting to make sure that you get those inequalities correct, you may read it incorrectly. So it's always good to go back and reread the passage and make sure that you've got those correct inequalities. So let's go ahead and graph this. Here we go. So since I can equal 13, I'm going to have a closed circle. 17, I don't necessarily have to equal 17, so I have an open circle, and then my ages are going to be in the middle. So if I write my interval notation, I'm going to have a bracket, 13, comma, 17, parenthesis. Okay, remember all those rules that we learned? Remember, when I have a closed circle, I have that bracket. When I have an open circle, I have that parenthesis. So we're making sure that we're following those rules that we've learned. All right, let's look at the next one. All right, everybody's favorite, the mall. Janet's store offers a discount on customers' purchases if they spend less than $20 or more than $100. Write an inequality to represent the amount that qualify for the discount. So you and your table partner go ahead and pause the video, work it, annotate your problem, and then come back to me and let's see what we got. Okay, so let's see what Janet's got in her store. So here we go. She offers a discount of purchases which they spend less than $20 or more than $100. So if I'm writing this inequality, obviously I'm going to have this $20, and obviously I'm going to have this $100. Now, my spending we're going to call X. Now, how does X compare to $20? It's going to be less than. Now, it doesn't say spend less than or equal to 20. It says spend less than 20. So like $19.99, but not the whole $20. All right, so let's look at the rest of it. It also says spend more than $100. So kind of like saying you can spend that $100 and a penny, but you have to spend more than that $100 bill. So let's see how we write that inequality. So I'm going to put a little bit more so I have room. I have my $100. And then I'm going to say that X is going to be bigger than. Now, Miss Kellen, you put your numbers in the middle and your variables are on the other side. That's true, because my spending is compared to the numbers. Okay, so just with what we've written, let's go ahead and graph this on a number line. Remember, we are graphing the meaning of the inequalities, not points or not necessarily how we think it should look with the way the symbols are drawn. We are graphing the meaning of these inequalities. So let's go ahead and do that. So I've got my number line. Always have a reference to 0. And then I have 20 and I have 100. So then, since it can't either 1 be equal to 20 or 100, I'm going to have open parentheses, and then it has to be less than, or it has to be greater than. So this would be an OR problem. So let's go ahead and write that and see what it looks like to write that OR problem. Here we go. So I've got, it starts at negative infinity and it goes to 20 parentheses or 100 and goes to positive infinity. We remember using those parentheses with the concepts of infinity. We remember using that OR symbol, meaning it has to be either this or it has to be this. So this is our OR problem because it even has it right here in our passage. Good job. Let's look at the next one. All right, bunch of people running. We got a marathon. Michaela is training for a 5K run. She wants to keep her running pace between 8 minutes per mile and 10 minutes per mile inclusive. She ran 3 miles and her total time was between 24 minutes and that is supposed to be 30 minutes. So I'm going to go ahead and fix that before I set you loose to work. It's supposed to be 30 minutes. Inclusive. Write and solve a compound inequality to find the range of her possible average pace per mile. So go ahead, you and your table partner, go ahead and work this. Pause the video, come back to me, and let's see what we got. All right, so let's see what Michaela did with her running. So I'm going to go ahead and annotate my problem and then work my inequality. So here we go. All right, so it says that she's going on her 5-mile K or her 5K run. She wants to keep her pace between 8 minutes per mile and 10 minutes per mile inclusive, which we learned what that meant. She ran 3 miles and her total time was between 24 minutes and 30 minutes inclusive. All right, so I'm going to go ahead and write that. So I'm going to put what I know first. It was between 24 minutes and 30 minutes, and she ran 3 miles. So that's 3 times her average rate. Now, how did that 3 times her average rate compare? The 24 was less than or equal to the 3x, or the 3x was less than or equal to the 30. So what I have here is my compound inequality, so I've got to solve for my variable. Remember, anything that you do to these compound inequalities, you must do to all of the parts. So let's go ahead and look at that. So that means since I'm multiplying the 3 and the x, I've got to divide. And if I divide in one part, I have to divide in all of my parts. So that means I have 8, which is less than or equal to my time, which is less than or equal to 10. So did she get what she wanted? Yes, she did. So let's go ahead and write that statement down telling what this inequality means. So here we go. So my statement says that Michaela's average pace per mile was between 8 and 10 minutes. So then if I wrote that interval notation, what would it look like? Exactly right. I'm going to have my bracket of 8, comma, 10, bracket. So then, did you go further and graph this? Let's see what it looks like graphed. All right, so I'm going to do a different color for my graph. So let's do red, just so we can see it. So I'm going to have my 0, my 8, my 10. It can equal, and then here would be my graph. Check my work, check your work. Make sure they look the same. Make sure that your interval notation is the same. Make sure that your graph looks the same. Now, you may not have written your statement, but that's okay. You need to be able to read a statement and say, hey, that's what I worked means. So you need to be able to look at your work and say, this is a statement that justifies my work. Good job. All right, so let's see what else we got. Lewis has a phone. All right, Lewis has a cell phone plan that charges 10 cents per text message. His monthly texting budget is between $20 and $30 inclusive. Write and solve a compound inequality for finding how many texts, which we'll use T, Lewis can send a month. So he can send a month. So go ahead and pause the video. You and your table partner work. Come back to me and let's see what we got. All right, so let's go ahead and reread our passage and annotate it, and then we're going to work our inequality. So here we go. I'm going to get a different color. Let's use green. All right, so Lewis, he has a cell phone plan that charges 10 cents per text message. His monthly budget is between these two inclusive. So what I'm going to do is I'm going to say that his text messages have to be between $20 and $30. Each of those text messages are 10 cents a piece, and they have to compare to that $20 and $30. So my text messages, which are in the middle of my inequality, has to be bigger or equal to $20, or my text messages have to be less than or equal to $30. So let's go ahead and work this. So whatever I do to one part, I have to do to all parts. So I'm going to divide by that 10 cents everywhere. So I have T left over. I have my inequality symbols. To me, that's a lot of text messaging. To you, maybe not. Maybe you do a whole lot more texting. But he can text between 200 and 300 text messages and still stay in his budget. So let's go ahead and graph this. Here we go. So if I'm graphing this, I have 0, I have 200, 300. I can have closed because it can equal those. And then I am graphing in the middle. Now let's go ahead and write our notation. Let's do interval notation. So here we go. So I can start with a bracket and 200, comma, 300. There we go. So with his cell phone cellular plan that charges our 10 cents a text message, he can spend between $20 and $30 just on those text messages. So you've got to make sure that you're understanding what these passages mean. That's why we're going ahead and going through and annotating them. Good job. Now, a certain medicine must be stored at a temperature between 36 degrees and 46 degrees. After placing it in a cooler, the temperature was measured at 2x plus 30. Write and solve a compound inequality to find the range of the value of x that keeps the medicine safe. So we're looking for the range. So go ahead and you and your table partner pause the video, work it, annotate it, write out all of your math, make sure that you're putting the notation, make sure that you're graphing, see what you can come up with, then come back to me and let's see what we got. All right, so let's look at this medicine. You may not know some medicines that you take cannot just sit out on the counter or just can't be in a pill bottle. Some medicines must stay in a refrigerated area or they go bad, they spoil. So that's what this problem is about. So we got a little science going on. So let's look, let's go ahead and annotate. So it says this medicine must be stored between 36 and 46 degrees. After it was put in a cooler, it was measured again, and this is what it measured. So I'm going to write and solve this compound inequality. So I know the lowest it can be is 36. The highest it can be is 46. And where it measured was somewhere in the middle. So I've got to put what this measurement is compared to this 36 degrees and 46 degrees. So let's look. So it says that it was measured and it has to stay between. Now, it can equal 36 and it can equal 46, but compared to 36, it can also be bigger, or compared to 46, it can be smaller. So what I'm going to do is I'm just going to get that variable by itself by subtracting 30 on both sides. So I have 6, 2x, and 16. Then I am going to divide by 2, and I have 3x and 8. So my temperature that I can have, if I get the numbers 3, any of the numbers between 3, including 3, all the way to 8, including 8, and I plug it up in my expression, that could possibly be what that measurement of temperature was. So this is how we look at this problem. So let's go ahead and graph it. So I've got, always referencing to 0, 3, 8. It can equal 3. It can equal 8. So I'm graphing. I have a bracket of 3, and I have a bracket after 8. Check my work. Did you get what I did? Did you do whatever in the middle you did to both sides? Making sure every time, just like our equations where I did something on one side of the equal sign, I have to do to the other side of the equal sign. With these inequalities, whatever I do to one part of the inequality, I have to do to all my parts of the inequality. Good job, guys. All right. At the 2 museums, children under 5 years old and seniors ages 65 and older get free admission. Write and solve a compound inequality to show the ages that qualify for the free admission. Go ahead and pause the video. You or you and your table partner work it, do all the parts that we've been doing with these inequalities, come back to me and we'll see what we got. Okay, so we're at the museum. 5 and younger, get in free. 65 and older, get in free. So let's go ahead, annotate, and work. So at the museum, the 2 museums here in Jackson, children 5 and under, get in free. 65 and older, get in free. So what I'm looking at is my age, which is less than or equal to 5, can get in free, and then my age, which is bigger or equal to 65, gets in for free. What type of inequality could we call this? Exactly right, it's an OR problem. So let's go ahead and graph this. So I've got 0, 5, 65. They can be 5 or younger. They can be 65 or younger. So, in all intents and purposes, this graph could start at negative infinity and go to 5. Oh, Miss Killen, you did not completely read what this says. So when I was annotating and reading this, I read it as children 5 and younger. But does my problem say that? No, it doesn't. It says what? Children under 5. Under 5. So can the age equal 5? No, it can't. So that's very good. So we saw that as we were writing. So my ages have to be less. So at this 5, would it be an open circle or a closed circle? It's going to be an open circle. So let's go ahead and fix that. Some of you were probably going, Miss Killen, you're not doing that right. And that's a good catch. So it's going to be an open circle. Now let's look at 65. It says, and seniors age 65 and older. So at 65, it's going to be a closed because 65-year-olds can be a part of that free admissions. That's a good catch. That's really making sure that we're annotating correctly. Good job. So then at this 5, instead of having a bracket, I'm going to have a what? I'm going to have a parenthesis or bracket for the 65 to positive infinity. That was a good catch. You've got to make sure that we're reading these passages and understanding exactly what they're saying, not what we think they're saying. That was a good catch, guys. Now, some things I want us to remember. Annotating your passages will help you see key words and phrases to solve these solutions, just like the age problem. Got to make sure that age was under 5 or 65 and older. All right, always read the words that represent your inequalities correctly. You have those and problems, or you have the or problems, what they look like graphed, and specifically what they look like when you write those notations. I'm so glad that you came here to learn with me here at MPB. We are at the end of our Unit 3. I've had a great time. I hope you have an awesome day.